Hey everyone, welcome back to the Python programming series. So, in our last module, we covered all the basics of variables and data types, right? We explored exactly how Python stores information, things like numbers, text, and true or false values. But let's be honest, data just sitting around isn't actually very useful unless we do something with it. So today, in this explainer, we're going to learn how to actively make Python perform actions using operators and expressions. Here's our quick roadmap for this explainer. We'll kick things off with a welcome to Python operators. Move right into doing math, making decisions, and combining conditions. Then we'll put it all together by building a real-world shopping calculator, and we'll wrap up with a quick mini challenge. All right, section 1, welcome to Python operators. To make sure we're all on the exact same page, think of variables as the nouns in our programming language. They hold the things. Operators, on the other hand, are the verbs. They're the action words that actually do the heavy lifting in literally almost every program, from simple calculators to massive AI applications. Basically, an operator is just a symbol that performs an operation on values. So if you look at the equation 5 plus 3, the plus symbol, that's our operator. The numbers 5 and 3 are the operands. So it breaks down like this. Operator equals the action, and operands equal the values being acted upon. Moving on to section 2, doing math. Arithmetic operators. So stepping into some really familiar territory here, we have the actual lexical grid of operator symbols straight from the official Python language reference manual. This basically shows the specific keystrokes Python recognizes to perform actions. Now, absolutely do not worry about memorizing all of these right now. Just notice how Python ingeniously uses standard keyboard characters to build an entire mathematical language. Let's break down the arithmetic basics we all know and love. We use the classic plus sign for addition and the minus sign for subtraction. For multiplication, you'll use the asterisk symbol. So a price of 20 times a quantity of 4 gives us 80. Easy enough, right? But definitely pay close attention to division, which uses the forward slash. If you tell Python to calculate 10 divided by 2, it's actually going to output 5.0. You see, Python division always returns a floating point decimal number, even if it divides perfectly evenly. Okay, let's level up our math skills with some slightly more advanced Python-specific symbols. Let's say you really don't want that decimal from regular division. Well, you can just use floor division, which is 2 forward slashes, and that simply chops off the decimal part entirely. Then we have the power operator, which is 2 asterisks, used for exponents. But the real game changer here is the modulus operator, represented by the percent sign. Modulus is brilliant because it returns the remainder of a division. So 10 modulus 3 leaves us with 1. And here's a super useful trick. If you take any number modulus 2 and the result is 0, you instantly know that number is even. Section 3, making decisions, comparison operators. Now this is where we pivot. We aren't just blindly doing math anymore, we're actually asking Python questions. And Python will always answer us with a definitive Boolean value, true or false. The absolutely crucial point here is distinguishing assignment from comparison. Listen, this is a massive trap for almost every new programmer out there. A single equal sign means assignment. It tells Python, hey, store the value 10 in the variable price. But a double equal sign, that asks the question, is the value inside age exactly equal to 18? Grasping this simple difference right now is literally going to save you countless hours of pulling your hair out debugging later. Of course, we have other comparison tools too. Not equal is written as an exclamation point followed by an equal sign. Then we have the familiar greater than and less than signs from middle school math. We can even combine those with an equal sign to check for greater than or equal to and less than or equal to. Just remember, whenever you're using these symbols, you're asking Python a direct question, and its output is strictly going to be either true or false. Section 4, combining conditions, logical operators. As you know, real-world logic is rarely just a single, isolated question. Usually, we need to check multiple things all at once. Python actually evaluates these logical statements sequentially, step by step, keeping perfectly true to the zen of Python philosophy that code should be beautiful and highly readable. First, Python checks the left condition. Then, it checks the right condition. Finally, it evaluates them together based on the words and or. If you use and, both of those conditions must be true. For example, is the user over 18 and do they have an ID? If you use or, only one of them needs to be true, like are they a premium member or do they have a coupon? Oh, and there's one more logical operator you need to know, and that's not. The not operator simply flips a Boolean value completely on its head. So if a variable called logged in is currently true, asking Python for not logged in will return false. It's a really handy way to just reverse a logical state perfectly. All right, section 5, real-world shopping calculator. Let's put the whole shebang together. This is the climax of our explainer today. We're going to take arithmetic, comparisons, and logic and combine them all into one beautifully functional mini-script. First up, we'll start by using our assignment operator to set up the data for our shopping cart. We assign the value 50 to our price variable and the value 3 to our quantity variable. Next, we bring in an arithmetic operator. We create a brand new variable called total, and we set it equal to price multiplied by quantity. Behind the scenes, Python quickly calculates 50 times 3, and it silently stores the value 150 right inside our total variable. And this right here brilliantly illustrates our next step. We want to know if this specific user qualifies for a discount. So we create a variable literally called discount, and we assign it the result of a comparison, total greater than 100. Basically, we're asking Python, hey, is the total we just calculated greater than 100? Because 150 is indeed greater than 100, Python evaluates the logic and confidently stores the Boolean value true in our discount variable. How cool is that? By combining just a few basic operators, we've programmed a system that can reliably calculate costs and make dynamic business decisions on the fly. Section 6, Mini Challenge and Recap. Take a quick second to pat yourself on the back and validate how much ground you just covered. Let's rapidly summarize so all of this information locks right into place. We learned the critical difference between operators, the verbs, and operands, the nouns. We covered basic arithmetic, plus those advanced tricks like floor division and modulus. We learned that the double equal sign is exclusively for comparison, and we explored how logical operators like and, or, and not let us combine multiple conditions effortlessly. Before we go, I want to leave you with this mini challenge. Can you open up your own Python environment and build a simple calculator yourself? Try this. Create two number variables, use the plus, minus, multiply, and divide operators on them, and then use a comparison operator to check if number 1 is greater than number 2. Apply this hands-on practice, and for sure, you'll be perfectly prepared for our next module, where we're going to tackle conditional statements, which is how we make Python choose completely different paths based on these true and false answers. Keep practicing, and thanks so much for watching this explainer.